Let's build an IoT Rails application in 5 minutes. First, let's create a new Rails application. Then add the Rails gem into our gem file and run bundle to make sure we have all the gems our application needs. And then run Rails generate Apiotics install to install our initializers. Next, we're going to go to the Apiotics portal and log in. Next, we're going to create what we call a Hive. A Hive is what we use at Apiotics to keep track of and authenticate all the different pieces of your IoT application. That includes devices, as well as your Rails web application that you use to control those devices. The Hive automatically generates API keys, which we'll use in our Rails application to authenticate to the Hive. The API keys get inserted into config initializers apiotics.rb. We'll be copying and pasting them, but in your production application, you should use environment variables for this. Next, we'll go back to the portal to create a worker. A worker holds configuration details for IoT devices that are associated with our IoT application. We'll call this worker an alert, and we'll use a Raspberry Pi 3 Model B Plus for it. Next, we'll select drivers for our worker. Since this is the Hey Blinken Hive, we want our worker to be able to have a button and an LED, so that we can blink the LED using the button. Next, we'll configure the ports for our peripherals. We have an LED and a button, and we don't want to plug them into the same port, so we'll use port D2 for the button. Now back to our terminal to use the scaffold generator to generate code for our Rails application. Instead of using the default Rails scaffolding, we're going to use the scaffolding provided by the Apiotics gem. Using Rails generate Apiotics scaffold alert, we're going to create a controller, models, and views for our alert worker. Next, we're going to run rake dbmigrate so that our database tables reflect the models we've just created with the scaffold. Because our device is going to be connecting using Wi-Fi, we use rake firmware Wi-Fi to set the Wi-Fi settings. We'll be connecting to a network called Ether, an open Wi-Fi network. Next, it's time to install our software image on the Raspberry Pi. Using rake firmware install, alert, the name of our worker, test unit, the name we give to this particular Raspberry Pi, we can do just that. After entering our passwords so that the installation can proceed, we'll need to confirm the disk that our image is going to write to in order to install the Raspberry Pi software. With that, the software we need, including the drivers we want, is installed on the Raspberry Pi automatically. After our Raspberry Pi boots up, we can go back to the portal to make sure that it's associated itself with our Hive. Under the Worker Instances section, we can see a new worker instance and its ID. Then in our terminal, we run rake devcoms start to start communication with our IoT devices from our Rails application, and then Rails S to start our web server. Now from our web application, we can easily turn the light on. Now let's get a little more ambitious. Let's use some custom logic in our Rails application to turn the light on our device on when we push the button. We're going to add a callback called blink using the after commit Rails callback, and then we're going to define the blink function. The blink function takes advantage of the fact that each driver on our device has a model within the alert module, and these models are associated with one another using Rails standard belongs to has one logic. And each instance of these models is associated with a particular IoT device. In the blink function, in the Grove Pi button model, which is the model for our button driver, we can say if the button toggle is true, turn on the light, and if the button toggle is false, turn off the light. And now we see it in action. We press the button, the light turns on. We press the button again, and the light turns off.